So question 10, this is angle and radius of a sector decreased by X% and 50%, and then so that the area is decreased by 90%. They don't tell you what is the changes here, but instead they tell you it's lead to this result, and then we have to chase back. Oh, that means how many percent decrease in angle will result in this way. So we draw properly first to understand the what is asking in this question. First, there is a sector with radius r and theta. What is the original values do not affect the result, and then this is the original one. And then they tell you that after some change, it's become a smaller sector. The radius is shortened, becomes 0.5 times of the original radius because they say 50% decrease, and the angle also smaller. Now the angle is theta and then 1 minus x%. On top of original 100%, we deduct x% from it, and then they tell you that this outcome, so the area is equal to A. And then this area, they tell you that the area decreased by 90%. That means this is no longer A, but this is just 1 minus 90% times of A. That means 0.1 A only. So here we are going to use R and theta to express A, otherwise it's difficult to find out. At the same time, A, that means pi r squared times theta divided by 360. This is A. And then we try to use r and theta to represent the new area. The new area is pi something squared and then something divided by 360. The new radius is 0.5 r, but not just r. The new angle of sector is theta times 1 minus x%. A very important thing to analyze it is to find out the original part from here. That means we isolate the change. If we do so, this is 0.5 squared. This factor, we can extract it outside. And then what is left is something original. We have pi r squared theta divided by 360 degree. So that means I just rearrange the order, and then we find out the original part, and that's representing A. And then we follow our calculation. This was 0.25 times 1 minus x%. And if we compare they tell us the final result is 0.1a. At the same time, if we use x% to express it, it is this times A. So what is the original area is totally not important. We divide both sides by A here. Then we get this equation. Copy again, that means 0.1. The factor from on the other hand, that means 0.25 times 1 minus x% here. Then we just simply solve this equation. So we know that x%, that means 60%. X is 60. Again, to calculate this, you don't need to care about alpha or theta. What you need to care is express the original area and also express the new area. After you find out the new area, you'll find that parts of it is from the original calculation. So you isolate that part. That's why you can finally eliminate it. And then we just focus on the factor here. 0.1 times. On the other hand, that means this 0.25 times bracket 1 minus x% times. And then we just focus on the factor here, and then we solve the equation. Finally, we get x.